Morning everyone. So I'm going to give you a whistle-stop tour of some scientific dating techniques that we employ at Zurich for archaeological understanding. So scientific dating allows us to establish an independent chronology that's free from any bias or artistic interpretation. And as I said, I'm going to cover two of these main types of technique. First, which is radiocarbon, and the second of luminescence dating. With radiocarbon, we can date anything that's been alive. You contain carbon within your bodies, and that exists in three isotopic forms. We have carbon-12, carbon-13 and carbon-14. Now, 12 and 13 are stable, but carbon-14 is radioactive, so we're all a tiny little bit radioactive. And it's this radioactive decay principle that allows us to establish a dating framework. Carbon-14 is produced in the upper atmosphere, and it's photosynthesised by green plants and quickly taken up into the food chain. Animals eat the plants, we eat the animals, and so on. So we uptake all this carbon-14, and because we're constantly replenishing the source of carbon-14, the decay that's taking place is offset. So we maintain this constant level of carbon-14 until we die. Once we die, nice morbid talk, only decay can occur, and this decay occurs at a known rate. With carbon-14, it decreases by 50% every 5,730 years, and that's what's known as the half-life. So if we can measure how much, if we know how much carbon-14 was in the organism to begin with, we measure how much is left. Because we know this constant rate, we can work out the time that's elapsed since death. This is valid up until the limits of the technique, which is about 50,000 years, or about 10 half-lives. So by the time we get to that point, there's so little C14 left that it's very difficult to measure, and then we have to start looking at other techniques. In the lab, we subject the samples to a variety of different physical and chemical processes before they get measured at our AMS facility out in East Kilbride. You can just see a little person over on the corner here, so that gives you the idea of the scale of the machinery that we need to measure. What we produce at the end is this dating certificate, which gives you a variety of different information. First thing everybody's looking for is the date, and you'll see that there's an error associated with that. Our standard precision is about plus or minus 35 years at the moment. But these years, these radiocarbon years, don't equate to calendar years, so we have to use calibration software in order to report that as years BC or AD. We also give some stable isotope information, which is that carbon-12 and 13 that I mentioned, and this can give some dietary indications, and it also acts as a quality control indicator. With regards to diet, what it can tell us, this is a very typical slide. I'm looking at the difference in C13 in a Mesolithic and a Neolithic diet. With a Mesolithic diet, we have a much higher reliance on marine resources, of coastal exploitation, and you can see that in the lighter C13 values. Moving towards a Neolithic diet, with more of the advent of farming coming in, we move towards a more terrestrial based signal. But at the end of the day, most people are looking for is the age. With archaeological dating, you do sometimes have some cultural implications, and none more so than have been brought to light with the dating of the Turin Shroud. But the information that scientific dating can bring to the heritage sector is invaluable. At Zurich, we've dated the remains from the Haute de la Garenne Children's Home in Jersey. We've dated some king in a car park or something, low profile. We helped identify the oldest stringed instrument in Europe, which was found in High Pasture Cave in Skye. We identified and dated the bishops of Whiphorn Priory. And we did some work at the Ness and Ring of Brodgar, looking at the relationship of that in terms of its relationship to when Stonehenge was built, and found it was earlier. Now, it's not always, these techniques aren't always used in isolation. For example, at Brodgar here, we did use some other techniques which are not so suitable for C14, and one of these was luminescence dating. Luminescence dating again lies on the principle where we have this ionising radiation all around us, and electrons are trapped in the crystalline lattice structure of minerals such as quartz. So we have these electrons stored until an external stimulus is added to be able to release these electrons in the form of energy, such as heating or exposure to UV light. This accumulation of these electrons or getting stored in the crystal lattice in the minerals during geological timescales. If we look at something that's containing quartz, for example, pottery, which is then fired in a kiln, we get this bleaching event which resets the signal back to zero. After use of the artefact, it's then deposited and buried, and you get this steady accumulation once again. When we get the samples discovered by the archaeologists, it's brought into the lab. We want to see how much energy has been stored here, and so with thermoluminescence we subject that to heating, which will give off the signal here, and we can work out the amount of years since burial. The precision with this varies. You can see here I've got a small table. 5% is a good precision, up to 10 or 15, but you can also see that the limit of the technique extends much further back than C14, so we can use this in a variety of different types of materials to help us answer more questions about sites. Some examples of sites, just as this is from one geographical location in one time period, we've looked at heated materials using thermoluminescence on ceramics and hearthstones. We've used optically stimulated luminescence, which is using light to release that energy, on wind-blown sands. This can tell us about storminess, site formation and abandonment processes, and we can link that into climatic changes in the North Atlantic system there. There's so little time to go through any more examples here, but we will have time to do this in the surgeries at the end. I'd just like to thank you all for listening, and I'll speak to you later.